Actions that occur in the data grid are most easily audited through the use of meta rules. Auditing the actions that take place in a data grid requires trapping actions at every policy enforcement point. An event can then be generated that describes when and who executed the action. Changes to state information generated by the action can also be tracked by a post-process policy. The events are stored in an external indexing system. The indexing system can be queried to summarize events. The result is the ability to correlate every persistent state change with a user action. The system can also correlate every persistent state change with a controlling policy and prove the correctness of the processing done by the infrastructure. The challenge is the requirement to be able to trap actions across all policy enforcement points. There is not a one-to-one correspondence between actions and policy enforcement points. A single action may invoke 10 or more policy enforcement points. The first approach implemented in a data grid modified the rule base for every policy enforcement point and inserted an auditing policy. This was a massive change to the rule base. In effect, the audit rules themselves needed to be audited for correctness. The second approach, currently being implemented, creates a meta rule namespace for auditing. The policies in the audit meta rule are executed first before the policies associated with the policy enforcement point. There is still a challenge in defining a generic policy that will capture the required auditing information for each policy enforcement point. Since all interactions with the metadata catalog are done through a query interface, it is possible to record changes made for each query and create an event that correlates the action with the state changes. To accomplish this, the rule engine is modified in iRODS version 4.2 to check the meta rule namespace for policies, apply the meta rule, then apply the original policy enforcement point rule. Note that meta rules are hierarchical with separately named meta rules executed sequentially. Thus, the audit namespace rules could be applied, then multi-level security rules, then the policy enforcement point rules. One could define meta rules that track actions separately from meta rules that track persistent state changes. This differentiates between internal consistency and external input. The iRODS data grid defines session variables that are appropriate for each policy enforcement point. Thus, session variables for $object path are only set when a file is being manipulated. Policy enforcement points for managing access controls will not set $object path. How can all of the appropriate state information be gathered for each policy enforcement point? Also, different sets of state information are changed depending upon the action. The system differentiates between collection operations, data operations, resource operations, and user operations. A description of the pluggable rule engine and the use of meta rules is available at irods.org, WP-content uploads 2015-06 zoo pluggable rule engine.pdf. Examples of the auditing approach based on modification of the policy at each policy enforcement point is available in Chapter 5.16 of the Policy Examples Workbook. This example sends the information to DataBook for indexing and is used to generate usage statistics for the DataONE interface. The approach based on the use of a meta rule will be available in iRODS version 4.2. This will track the arguments of each action and the environment associated with each action. The approach implies that all actions on the data grid will have been virtualized. An action will be represented by its input parameters and the environment in which the action is performed. Take 7 minutes and complete exercise 108. Identify the set of events that you believe should be audited. Consider not only changes to your collection, but also changes to the repository environment. Please load a paragraph describing your result into the lifetime library in the sub-collection class INLS 624 by the end of today's class. The Data Observation Network for Earth is an NSF-funded project to support environmental data sets. The project was established in October 2009. The DataONE website is listed here, www.dataone.org/what-dataone. DataONE provides a registry for environmental data collections. Researchers can search the registry to discover relevant data sets. The registry is replicated across 3 sites to minimize risk of information loss. When a file is found, DataONE supports access to the site that registered the file. The researcher retrieves the file from the submitting site. The 3 sites where the registry is distributed are called coordinating nodes. They are located at the University of New Mexico, the University of California at Santa Barbara, and the University of Tennessee. The places where the datasets reside are called member nodes. Software provided by DataONE is installed at each member node to support registration of files and to support access to files from DataONE tools. The DataNet Federation Consortium has ported the DataONE member node software on top of the iRODS data grid. Any project using DataGrid middleware can then register their collections into DataONE through the DataONE registration processes. A DataONE member node is required to provide a minimal set of capabilities. These include supporting the DataONE member node service to enable access by DataONE tools and services, generating a unique ID for each file. A local instance of the handle system is used to generate the unique IDs. The resulting URI can be embedded in a paper and used to retrieve a copy of the file. Providing standard metadata to support discovery, including date and location metadata for observational data. Generating usage statistics that track accesses. Registering the member node with DataONE. This requires approval from DataONE. There are 2 operational concerns. Datasets are assumed to be immutable after they are registered. Updates to the collection are periodically harvested by DataONE through the member node software. The DataONE project has developed multiple tools to assist in research. They include DMP tool supports creation of a 2-page data management plan. In Chapter 7 of the Policy Examples Workbook, a list of DMP requirements is provided along with examples of policies that automate the tasks implied by the requirements. OneMercury is a web service for searching the registry. The web service supports spatial queries as well as searches on descriptive metadata. Zotero is an external service that is integrated with DataONE. Zotero supports creation of web-based bibliographies. Oner integrates access to DataONE registered files from the R statistical analysis system. Morpho is an open source metadata editor that supports submission of data and metadata to a member node that runs the Metacat software stack. Kepler is an open source workflow environment that can access DataONE registered files. OneDrive is a new tool that will support the mounting of DataONE registered collections as a file system.